Okay, so now adding friction to number 2. When you add friction, you have to go back and do the sum of the forces in the y over again, because the normal is not going to just be Fg over cos theta, because now there's friction in the y. So sum of the forces in the y, so going up is still Fny, going down is still Fg, but now also going down is friction in the y direction. Okay, so Fny is still Fn cos theta. Fg is still mg, and I'm going to take it over to the other side. And friction is really mu Fn, and it's sine theta. It's the opposite side, and that's going to be equal to mg. So now factor out your Fn, because that's what you're always trying to solve for in the y direction. So cos theta minus mu sine theta, and then divide by the bracket. So Fn is equal to mg over cos theta minus mu sine theta. Okay? Once you have that, then go to the x direction. So sum in the x will equal mv squared over r, and this time in the x, there's both Fn in the x and there's friction in the x. And they're both going towards the center. So it'll be Fnx plus friction in the x is equal to mv squared over r. Fnx is Fn sine theta, and friction is mu Fn, and if you look, it's the adjacent side, so it's cos theta is equal to mv squared over r. Okay? So again, before you fill in, factor out your Fn. So it'll be Fn bracket sine theta plus mu cos theta is equal to mv squared over r. And now sub in what you had for your Fn here up here. So it'll be mg bracket sine theta plus mu cos theta. And on the bottom, it'll be cos theta minus mu sine theta. Okay, so we're just subbing that in for Fn. And that'll be equal to mv squared over r. So the m's are going to cancel, cross multiply, so that it becomes gr brackets sine theta plus mu cos theta is equal to v squared brackets cos theta minus mu sine theta. Alright, so now you're going to multiply through, so you'll have gr sine theta plus mu gr cos theta is equal to v squared cos theta minus mu v squared sine theta. Solving for mu, so take your two mu's to the same side, so bring this guy over and take this guy over. So you'll have mu gr cos theta plus mu v squared sine theta is equal to v squared cos theta minus gr sine theta. Okay, pull out your mu, so it becomes mu brackets gr cos plus v squared sine. The other side just stays the same. And now divide by the bracket. So mu will equal v squared cos theta minus gr sine theta divided by gr cos theta plus v squared sine theta. And now fill your numbers in. Now be careful when you're filling in for v. It's the second v, because it wants to know what's the coefficient of static friction for the car not to skid traveling 90 kilometers per hour. 90 kilometers per hour is 25 meters per second. If you mess up and fill in the original speed, what's going to happen is you're going to get 0 for the coefficient, because it can go around without friction at the original speed. Okay, so fill in the angle that you had, and then it's minus on the top 9.81 meters per second squared. The radius is 70 meters, that hasn't changed, and the angle again 22.02, I think that's 388, and then on the bottom 9.81 meters per second squared 70 meters, cos of 22.02388 again, plus the 25 meters per second squared sine of the 22.02388. Okay, so now all that's left is, can you punch this into your calculator correctly? If you can, and you don't forget the squares, and you don't forget your brackets, you should get 0.3696, I think. Yes. 3696. Okay? So now I'd like you to do numbers 3, 4, 5, 6, as well as number 7 and 8 on the back of that original sheet. I thought about starting amusement park stuff, but I think I'll wait till tomorrow. Oh, it's finally snowing. I'll wait till tomorrow. Hopefully tomorrow we'll only need to go over the ones that mess you up here, which will probably be number 3 and perhaps number 4. Okay, so good luck, and if you have issues, please post in the group and I will help.